Continue on with our lesson on hyperbolas with a few more problems. This one just wants us to write an equation of a hyperbola with the center at the origin, one focus at the point 3, 0, and one vertex at the point -2, 0. So with the center at the origin, I know I'm going to have x squared and y squared without adding or subtracting any values. And then the focus and the vertex both being on the x-axis tells me that my transverse axis will be the x-axis, so my x value will be positive and my y value will be negative. The focus gives me my c value and the vertex gives me my a value. And I know that c squared, which will be 9, is equal to a squared, which will be 4, plus b squared. So that tells me that b squared is 5. My a value always goes under my positive variable, so that's a 4 underneath x squared, and my b squared value always goes underneath my y squared, or my negative variable, I should say. In this case, it's y squared. So there's my equation. Next, they're giving me vertices 1, 2, and 1, -2. That tells me that my center is at the point 1, 0. And also, because the vertices go up and down on the y-axis, that tells me that my transverse axis will be vertical. So actually my transverse axis is going to be the line x equals 1. Now, the vertices being at 2 and -2 tell me that my a value is 2. And then the foci are at 4 and -4, so my c value is 4. So if c squared, don't need that squared there because 16 is already squared. C squared is 16 is equal to a squared, which is 4, plus b squared. Then I know my b squared is 12. So let's write the equation. If my hyperbola opens up down, then my y value is going to be positive, and the center for my y value is 0, so I don't have to add or subtract anything to y. Then, of course, a goes with the positive term, so I have a squared is 4. And then the x value of the center is 1, so I do have to subtract 1 here. And my b squared value goes with the negative term, so that's a 12. And then I have equal to 1, and that is the equation of the hyperbola. And the last question we're going to work on is one that I actually have to put in the correct form. I have to put it in vertex form by dividing by this 4 here. So I'm going to have y squared over 4 minus x squared equals 1. And I know that the parabola is going to open up, down. The hyperbola is going to open up, down because the y squared value is positive. I know that my a value is going to be 2 because a squared is 4. My b value is 1 because b squared is 1. I know that my center is the point 0, 0. And since I open up, down, my transverse axis will be the vertical line x equals 0. The conjugate axis will be the horizontal line y equals 0. C squared equals a squared, which is 4, plus b squared, which is 1. So c is the square root of 5. The vertices go up, down. So I start at 0, and I go up by a, which is 2, and I start at 0, and I go down by a, which is -2. The co-vertices are going to go left and right by b, so -1, 0, and 1, 0. Let me go ahead and start graphing what I have. My vertices go up and down by 2, co-vertices left and right by 0. I can draw my box. I'm going to go ahead and put in my slant asymptotes. One there. These are quite small slant asymptotes. There we go. And then I'm going to go ahead and put in my foci, which are up and down by rad 5, a little over 2. And then from my vertices, I can draw my hyperbola out toward my slant asymptotes. And I am left with just needing to put in my foci, which are at 0, rad 5, and 0, negative rad 5. And then the equation of my asymptotes, since I sit at the origin, I just need y equals plus or minus, and it's the square root of the value under y squared, so 2, divided by the square root of the value under x squared, or 1. So my slopes will be plus or minus 2 times x.